So I'm here today with my little friend to talk about our first science videos beyond the introduction. So obviously this is my guinea pig. His name is Annie, as in Anakin. He's named a few reasons because, one, I like Star Wars too much, and two, he's kind of a jerk, and three, he's got the red creepy eyes like Anakin did at the end. Hopefully our little friend here will demo our videos for the biology, physics, and chemistry class. For those who don't know, this is a guinea pig. The guinea pigs, or the scientific name, is Cavia parcellus. And basically all they do is just eat, sleep, and go to the bathroom. But hopefully today he can do some tricks that are useful to us. Okay. Hello, 9th and 10th graders. This is high school now. Apparently me doing chemistry talks in the living room with my good friend here, Annie, the guinea pig. So last time we talked about physical versus chemical change. And I would like us to progress to the next stage, which is talking about the actual chemistry going on behind the physical and chemical changes. That being endothermic and exothermic reactions, just like the one we did on pretty much the very last day of school with the different, not beakers, test tubes with the different chemical reactions. Remember, one of them went really cold. That was an endothermic reaction, as all the energy is being absorbed in, leaving that cold feeling. And then the other one, which was really warm, which was the exothermic reaction, which is everything coming out, creating that heat, just like a flame or an explosion, various things like that. With that being said, we're going to transition, like I said, into talking about what is actually going on. And that introduces us to the idea of the atom, which is the smallest particle, originally thought to be the smallest particle at the time, and what most of the periodic table in chemistry is based off of. Alright? So, atoms, they make up everything, literally everything. They're in this piece of lettuce, they're in this blanket, they're in this table, they're in that cup, they're in the water in that cup over there, and they're in this pig. This pig right here, who's probably peeing. No, not peeing yet. Close to peeing. Alright? Now, for us, humans, and him, we're all made of an atom called carbon. And most, because there's always weird exceptions out there in the world, and the universe is a very big place. Most of the life that we are aware of is made out of carbon, which is C on the periodic table. Okay. We'll go over the periodic table in due time, but just understand the idea is that everything is made by these atoms, which have three tiny particles inside of them, which is the protons and neutrons, which are in the nucleus, followed by the electrons, which is the orbiting around. So if you imagine he's the nucleus, and we have different particles, say here, here, here. Those would be the electrons, and they would be going around in various ways, interacting with each other. When you get enough of these atoms together, they start forming molecules or compound molecules, which are then held together by different types of bonds. We'll talk about each one of these bonds later, hopefully in some way. Haven't thought that one out yet, but we'll figure it out. So, everything's being held together, just like him. We have various types of atoms, right? So this blanket is also carbon. This guinea pig is carbon. This blanket's carbon because it's made out of cotton, right? The glass holding this water is made out of silica, which is another type of atom with a different arrangement. So each time we switch atoms, they have a different arrangement of protons and electrons. The H2O, or water, in the glass has two other atoms, hydrogen and oxygen. Again, those are two different arrangements. So again, this is a sort of an introductory video to kind of the bigger world of what we're going to be taking a look at with the types of elements. You guys already did an assignment picking one of your elements of your choice, so you have a rough idea of what is actually happening at different levels in the periodic table. Oh, he's gonna make a jump. You guys stay up here. Alright, so the goal right now for our class, like I said, is to just introduce you to the idea of atoms making up every single thing. And not all the atoms are very common. Some are very, very common. The first 20, possibly up to the first, you can argue up to the first 40 of the periodic table are very common and found throughout the planet. Roughly up to 40, because 40 is about where iron begins. Everything beyond that is actually made by supernovas exploding, creating those heavier, denser metals and non-metals. So, on that note, I'm going to leave it here, and then the next time we're going to hopefully talk about the periodic table, and I'll have an actual visual one to show, and we'll talk about the 3 different types of subatomic particles in the atom that help create that periodic table. So, until then, have a great day, stay healthy, stay safe, all high schoolers. Talk to you later.